Today we will discuss about centrifugal pump. So welcome to my YouTube channel Mechanical Engineering Management. Like, share and subscribe. First of all, definition of centrifugal pump. It is a hydraulic device which converts mechanical energy into pressure energy by centrifugal force acting on the fluid. So I have actually divided the definition into the parts, so it is very easy to remember the definition of centrifugal pump. Now next, main components of centrifugal pump. First component, impeller. It is a rotating part of a centrifugal pump. Whirling motion is given to the liquid by means of backward curve vanes. It is mounted on the shaft which is coupled to electric motor. So here I am going to show you one more interesting point, that how you can draw the centrifugal pump in the examination. So concentrate in the whole video, so automatically you can remember each and every points of the centrifugal pump as well as the steps to draw the centrifugal pumps. So first I am going to draw the part 1, impeller. So this is the center line of the pump and here it is the impeller. And these are actually the backward curve vanes. And as per the description, impeller is a rotating part of the centrifugal pump. So it is rotating like that in clockwise direction. And so that whirling motion is given to the liquid by means of these all vanes that is mounted on that impeller. So I will give the name. This is the impeller. It is mounted on the shaft which is coupled to electric motor. It is called as the eye of impeller, and this is the shaft that is connected to the electric motor. Now next part, casing. It is an airtight passage surrounding the impeller. It is designed with gradually increasing area. This is very important point, gradually increasing area along the flow direction. So I am going to draw over here casing. And here you can see this is actually flow direction starting from here to here, and you can see the area is going to increase gradually. So I will give the name over here. This is the casing and that is supported by the frame. And this is called as the volute casing because of the area is going to increase, then it is known as volute casing. Although there are so many types of the casings available, but here I have shown volute casing. This is sometimes known as spiral casing also. Next, suction pipe. The upper end of suction pipe is connected to the eye of the impeller and lower end is submerged into the sump. So I am going to show over here the suction pipe. Upper end of suction pipe is connected to the eye of the impeller. That means this one is the eye of the impeller, or you can say the center line. Here suction pipe is connected with the eye of the impeller and lower end is submerged into the sump. So this is the lower end that is submerged into the sump. So this is sump which is filled with the water. That is sometimes known as the storage tank also. This one is the suction pipe. This one is the sump, or you can say sump tank. Now next component, strainer. It is used to prevent solid particles, debris, etc. into pump. Strainer that is actually at the lower end of the suction pipe to prevent debris, solid particles from the sump to the pump. So I am going to draw the strainer. Give the name. Next, foot valve. It allows water only in upward direction. So sometimes it is called as the non-return valve, and that is very near to the strainer. So this is foot valve and that is open in the upward direction only, so that you can see it allows water only in upward direction. So I will show you how it opens. So it is like that. When the pump is in non-working condition, So it once again regain its position like that. Give the name first. Next, delivery pipe. Lower end is connected to casing and upper end is connected to overhead tank. So I am going to draw over here the delivery pipe. Lower end is connected to the casing, upper end is connected to the overhead tank. So this is overhead tank that is also filled with the water, and our objective is to lift the water from the sump to this overhead tank. So sometimes this tank is known as delivery tank also. So I will give the name delivery pipe. This is the delivery tank, or it can be overhead tank. Now next, pressure gauge. It is used to check pressure of fluid in delivery pipe, and that is also near to the casing. So this is the pressure gauge. And you know that always the pressure is above the atmospheric pressure in the delivery pipe, and that's why it is called as the pressure gauge. Vacuum gauge. It is used to check pressure of fluid in suction pipe, and that is also near to the eye of the pump. And you know that in the suction pipe the pressure is always below atmospheric pressure. So you can see it is the vacuum pressure inside the suction pipe, and that's why vacuum gauge is there. Now next, delivery valve. It is used to regulate supply of liquid from the pump to the overhead tank, and that is also near to that pressure gauge. So this is the delivery valve. So we are going to mention over here the important terminology also in this figure. Sump level, the water level in the sump, that is called as the sump level. And this is called as the discharge level, the level of water in the overhead tank. And so that I can mention over here, this is the suction head, that means from sump level to the center line of the pump. And this one is called as the delivery head, and it is denoted by HD. And HS plus HD is known as the static head. That means the head against which pump has to work. Now I will show you the very interesting point, that is the flow of the water from sump level to the overhead tank. So look at carefully. Now the question is how it works. So the next point is working. So impeller is rotated by means of electric motor. This creates vacuum at the eye of the pump so that liquid rise in suction pipe. So here you can see the impeller is rotated by means of electric motor, and so that it creates a vacuum at the center of the impeller, and over here the liquid is at atmospheric pressure. So due to that pressure difference, liquid rise in the suction pipe. Next, liquid is continuously sucked and passes through the eye of pump. So liquid is continuously sucked and passes through the eye of the pump. Then liquid enters the casing through this blade passage, where pressure increases by reducing the velocity. Here you can see the area is also going to increase along the vane passages, and so that the pressure is increased. Similarly, in the casing, area is also gradually increasing, and so that once again the pressure is increased. Due to that pressure, the fluid rise in the delivery pipe. So due to this rise of pressure, the liquid passes into the delivery pipe and is lifted to the required height. So thanks my dear friends. Press the like button to appreciate this video.